AI agents are powerful, but they're missing something critical. They can't see how your data connects together. Knowledge graphs solve this problem, and by following along with me step by step, by the end of this video, you'll have built your very own custom knowledge graph in Neo4j, along with a graph agent in n8n that can intelligently navigate complex data relationships. And I know knowledge graphs can sound intimidating, but we have a secret weapon, the Neo4j MCP and Claude Desktop. With this, you can literally talk to your graph to make changes, add data, retrieve information, so there's absolutely no need to write custom Cypher queries or anything like that. But I'm not stopping there. I'm going to demonstrate two highly practical real-world use cases that showcases the true power of knowledge graphs and agentic retrieval in n8n. The first is our Customer360 GraphAgent that gives you a complete view of your customer and their interactions with your business. And the second is our document structure graph that intelligently navigates complex documents like legal contracts and regulations. I've put a ton of work into this one, so I'd really appreciate if you give the video a like below and subscribe to our channel for more AI and n8n content. It really helps us out. Let's get into it. Let's start off with a quick explainer on what is a knowledge graph. And essentially, a knowledge graph is a way of storing information that focuses on the connection between things. It's a web of interconnected points where each point represents something. So here, for example, I have Emma Williams, which is a customer, and Emma Williams placed this order, order number 2. That order contains a phone case, which is a product. So you see these lines in between these points, and they represent the relationships. So this order contains this product. Emma Williams placed this order. Emma Williams raised this support ticket on a product defect. So it is possible to do this in a more relational database. You could have a customer table, you could have a support ticket table, an orders table, and then you would use foreign keys to interconnect the records in the tables. But knowledge graphs are more flexible. You don't need rigid foreign keys. You can draw connections to any entities very easily. And with a property graph like this, these nodes and edges, or entities and relationships, essentially have properties. So you can see on the right here, Emma Williams has an email address, a join date, the total spend on her account. Or if you look at this order, which contains this phone case, if you click on contains, it shows the price is $19.99, and one of these phone cases is included in that order. And that's a knowledge graph in a nutshell. You have nodes, you have edges, and you have properties. So it is a data store the same as a relational database, except it's more like a mind map instead of a spreadsheet. And that makes the connections between nodes or entities easier to visualize and then easier to explore. And you can model lots of things in a knowledge graph. So here I'm modeling customers and orders and products. But in this knowledge graph, I'm actually modeling a document. So here we have different chunks, and it's a legal document. So we have legal clauses that are included in the chunks, and everything is then interconnected and related. So you can see here that this text chunk comes from clause 10, but it actually references clause 5.2. So that way we can intelligently load up all of the cross references in a document. So the way you actually retrieve data and traverse a graph like this is by using Cypher, which is a specialized graph language. So here's an example Cypher statement. We're looking to match all of the nodes where the customer name is Michael Chen, and we want to return the nodes, the relationships, and the other connected nodes. And if I copy that in here, paste it at the top and execute, you can see that there we have the Michael Chen node and all of the relationships and interconnected nodes. So then to traverse within this browser, you just double click. So you can see he placed order 009. If you double click there, that included a phone case, a Bluetooth speaker, and a desk lamp. If you click on the phone case, you can see that that was also ordered as part of order number 2. If you go to this query that he raised and double click it, you can see that that technical issue was about that Bluetooth speaker. So it's easy to visually explore the graph and discover hidden connections that will be difficult in flat database tables. But obviously the barrier to entry here is needing to know Cypher to be able to query this. And thanks to AI and particularly MCPs, that's no longer a barrier. Because in this video, I'll be showing you how you can set up the Neo4j MCP with Claude Desktop and then just chat to your graph. Give me a list of all orders that Michael Chen has placed, along with any of the support tickets that he's created that are still open. So it's now using the MCP to go to the graph database, first just to get the schema, and then it dynamically creates the Cypher to actually fetch the information. And we can see Michael Chen has 2 orders, and now it's going to check the support tickets. No open support tickets, but he just has 2 closed tickets for reference, and these are the ones that we saw in the graph. So if you are getting started with knowledge graphs, learning Cypher is no longer a blocker thanks to the likes of Claude Desktop and this MCP. I'll show you how to set this up in a few minutes. An important aspect of knowledge graphs is your data sources. Are you extracting structured data from the likes of spreadsheets, database tables, software applications? Or are you processing unstructured data like what you see in PDF files, Word documents, meeting transcripts, etc.? Because as you saw in this knowledge graph, there is a dependency on the data being structured. We have all of these properties here, these nodes and relationships are all defined. So if you're processing unstructured data, you need to glean the entities and the relationships from the text. And nowadays, a lot of that is done using LLMs and AI. And that was the approach taken in my GraphRag video on this channel, where I used LightRag to extract out nodes and edges, and then carry out a deduplication process before uploading to the knowledge graph. I'll be going through examples of both structured and unstructured data sources in this video. If you'd like to get a head start and get access to our Customer360 GraphAgent, as well as our graph-based context expansion system, then check out the link in the description to our community, the AI Automators. To create your first knowledge graph, you're going to need a graph database. In this video, I'm going to be using Neo4j, which is one of the most popular graph databases out there. Neo4j does have a free cloud plan, however, it's not possible to hit this from n8n. So instead, in this video, I'll be self-hosting Neo4j on Elestio, which is a fully managed DevOps platform, and it allows you to deploy an application like Neo4j with the click of a button. So for that, create an account and log in, and then simply click Create a New Service on the top right, which brings you to this page, and then just search for Neo4j, which is there, click Select, choose a cloud service provider, so I'll just use Hetzner and their lowest plan, which comes in at $15 a month, and click Next. And that's pretty much it. You can leave everything else as is, and then click Create Service on the bottom right. And after a couple of minutes, your service is up and running, as you can see there. And if you click Display Admin UI, that'll give you the link to the admin interface that you can then log into. And it gives you the username and password as well. So really easy. Okay, we're connected. Now there's one change we need to make before we continue, which is we need this add-on library called APOC. This essentially allows us to carry out dynamic Cypher queries on the graph database. So to get this up and running, if you come back into Elestio, click on Update Config on the software, and then just paste in the following lines underneath environment. I'll drop these in the video description, but what we're doing is just enabling this library. Then you can click Update and Restart, and then that brings back up the containers with that extension enabled. You can see there, installing plugin APOC. Great, so we now have our graph database set up on Elestio. So if you click Let's Go under the Try a New Hosted Browser, this is a different UI into your graph database, but it's quite nice to use. So you just need to drop in your details again, so you can get the connection URL from here. So we'll just copy that out, and then the password is set here. So copy that, and then we can click Connect. Okay, so we are now connected. So at this point now, you have your graph database, but there's no information in it. So if you click this button underneath nodes, that's loading all of the entities on the graph, but you don't have any, so nothing's actually showing. The next step is to start loading data into your graph. So for this, we're going to use Claude Desktop and the official Neo4j MCP to manage our graph for us. First off, install Claude Desktop if you don't already have it. Then go to the official Neo4j MCP repo. I'll leave a link for this below. And as you can see, we now have our prerequisites met. We have Neo4j, we have the APOC plugin installed, and Claude Desktop is our MCP compatible client. So click on this releases link, and from here you need to download the binary of the MCP server. Under the latest release, click Assets, and then pick the specific server for your operating system. I'm using Windows 64-bit. And from there, you'll have a compressed file. And once you extract it, you'll have the Neo4j MCP.exe file. So just copy that out and then just paste in that exe file here. And then open up Claude Desktop, click on the burger menu on the top left, go to File Settings, hit Developer at the bottom, and then click on Edit Config. Now I already have my existing MCP set up here. Edit Config brings you to this folder with this file selected. So just open this up in Notepad. This is your Claude Desktop config.json. So I've just removed my existing one just to show you how this works. So within the GitHub repo, they give you the JSON you need to add to this. Copy that out and then paste that in here. And then you just need to fill out your details for your particular graph database. We need our address, which is this one here. And you can replace the Bolt localhost address with that one. Our username is Neo4j as well as the database name. And the password is what is set in Elestio, which is here. So you can just copy that, paste that in there. and I'll just add back in my other MCP server for my other Neo4j graph database. Okay, that's it. So we'll save that file, and then you just need to close Claude. And now if we go back into File Settings and Developer, yeah, you should now see your server, and I have my 2 servers set up here. This is the demo one I just created. So let's start chatting to this database now. Can you add 2 test nodes and a dummy relationship to my demo graph database? Okay, so I can see the available instances. It is hitting MCP demo. That's the one I created. And let's allow it. Okay, so it's added the 2 nodes as well as a dummy relationship. So let's now actually check our graph. Come back into the browser. And now on the left, you can already see the labels have shown. And if you click on this asterisk, there we go. There's our test node. And if you click on the asterisk under relationship, you can see the relationship between them. Excellent. Now, the one thing about Neo4j is you only get a single database per installation. So what I like to do is have an arbitrary parameter called GraphID. And that way then I can kind of segment the nodes and relationships within the database. Let's come back into Claude. Can you delete out that data now from my demo graph database? And also, can you create a small data set representing Game of Thrones entities and relationships, let's say? And can you create a new tag for these nodes and edges called GraphID? And let's set it as Westeros. And that way I can have different graph IDs for different data sets. Okay, so there's a bit to do there, but this is the beauty of having Claude actually manage your graph for you. So it's deleting the test data first, which is done. And as you can see, that's updated there. And now we're not getting any results. And now it's creating a Game of Thrones data set with my graph ID tagging system. So it's creating some houses, locations, characters. Okay, so let's try it. Allow once. And let's have a look at it. Okay, there we go. So we can see Jon Snow resides at Castle Black, belongs to House Stark, which rules Winterfell. House Lannister is an enemy of House Stark. So that's how easy it is to get Claude to actually manage your graph. And as well as inserting data like this, it can also update. So let's just pretend Jaime Lannister marries Sansa Stark. Can you create a connection between Jaime Lannister and Sansa Stark because they just got married? So it's written the Cypher query. And now let's have a look. Jaime Lannister, Sansa Stark, and they're both married. So that's how you can update your graph just by using your voice. And the fact that we have graph ID now set to Westeros. If I come into Claude and I ask it, can you create a data set similar to this, but now for The Witcher, and give it the graph ID The Witcher. Now you can click always allow, and then that'll set it within the session that it'll automatically execute these Cypher queries. I prefer to actually see what it's doing though, because it has master access to the graph. It could delete everything if a request was misinterpreted, so it is nice to actually sanity check the queries. I'm not a Cypher expert, but it is quite readable what it's actually doing. So I've approved that, and it has executed it, and there we go. We have our factions and locations. Now, when I refresh this, I'm not actually seeing it all, and it's because the limit at the top is set to 25. So let's just set that to 1000. And then you can run it again with this button. Okay, so we now have our 2 subgraphs within our database. This one is Game of Thrones, this one is The Witcher. So now what you can do is start filtering within the browser. And this is where you can ask Claude to create queries for you. Can you provide me a query to use within the Neo4j browser where I can pass in the graph ID and get back all nodes and relationships? And it gives you the Cypher query, so you can just copy that out, and then up here, we'll paste it in, and it has Westeros set as the graph ID. So now if I run that, now I'm only getting the Westeros ones. House Baratheon's off on its own here for some reason. But if I swap this out now to The Witcher and run it again, now nothing returned because it's actually all lowercase with no space. And there we go, there's The Witcher. And we have a couple of isolated nodes, and I think probably what happened was the relationship wasn't actually tagged as The Witcher, and that's why they're shown as isolated. But that's something that we could get Claude to fix up. And that's why it is worth looking at the queries that it's creating. Now, the other thing you can do is save these queries. This button to the left of the run query is to save the prompt. So let's call this one The Witcher graph. We can save that. And then that shows up in the saved Cypher list. So you can collect all of these queries that you use to navigate and inspect the graph. That way you don't have to go to Claude to create the Cypher each time, or you don't need to learn Cypher to be able to write it. And I already have quite a lot of saved Cypher queries that I'm actually running here. We now have our graph database. We've loaded in data using Claude Desktop and the Neo4j MCP. So now how do we create our graph agent? How do we hook this up to n8n? If you go to your n8n instance, and let's actually just chat to the data first. So let's click on add first step, and we'll add a chat trigger, and then we'll add an AI agent. We'll choose a chat model. Again, I'll go with Anthropic's 4.5 Sonnet, which is pretty good at creating Cypher queries. And when it comes to communicating with your graph database, there are a few options. So there is no official Neo4j node in n8n. However, there is a community node that you can use. So I have that installed here. And the way you actually install that, let me just show you. You go to your settings and then go to community nodes. Now, I believe this only works on self-hosted n8n. You can just click on install on the top right, and then you just need to find your community node. So click on browse. You just type in Neo4j and click search. And there are a few of these packages available. I'll use the one that has the most downloads, which is this one. And then you're simply just copying out the actual name of the repo. So n8n-nodes-neo4j. You drop that in there, agree to the terms and conditions and click install. And then that will install that community node in your instance, which then means you can add this node as a tool to an agent. And then you need to create a credential, which is the same as before. You just drop in your connection URI, the username and password and the database, click save. And then for this tool, let's just give it a resource, which is the graph database, and we'll allow it to maybe execute a query. Index name is irrelevant because it's not a vector database. And for the Cypher query, we'll just let the AI populate this. Okay, so I don't have a system prompt set yet, but let's just try it. So let's say, tell me about The Witcher. See, can Claude figure it out? And it sure can. Yeah, it's hit the execute query. And we do have some nodes coming back. Okay, here we go. Based on the database, here's a comprehensive overview of The Witcher. We have our main characters. There's Yennefer, the political landscape, there's Sintra, and the various locations. And you can see from that tool call then that we have got the various responses, which are the nodes, and you can see the Cypher queries then on the left. So it's figured out the graph ID equals The Witcher without me even saying it, which is brilliant. Okay, so that is how you create your graph agents. This AI agent can now execute arbitrary Cypher commands based off text prompts within n8n. And now, of course, this is just a test, it's dummy data. But the fact that it can execute arbitrary queries is both great and very dangerous because it could delete everything in your graph. So two ways around that then would be to create a read-only user. So when you're creating your connection here, you're using a different username, not the root username, along with that user's password. Or the other approach would be to create prepared statements. So if we come back into this execute query, and instead of allowing the AI to generate the full query, we could delete that out. And here then you could paste in a query that either you write or the AI writes. And from here then you could drop in different parameters. So let's say you want the AI to actually fill out whether it's The Witcher or Westeros. So you drop that in here. So it's from AI, graph ID, and then you can describe, choose either The Witcher or Westeros. Okay, and now if we try it again, give me information on Game of Thrones. And now it's executed that query, but it's now not an arbitrary query. It's only actually populating the graph ID. So it's a fixed prepared statement essentially. Now the query returned empty results, so maybe I got the graph ID wrong. Yeah, so it's Westeros with a capital W. Okay, we'll try it again. Yeah, and it has come back with data now. Okay, there we go. Major houses, key relationships, key locations. Job done. And there's your graph agent. The next question then is how do you load data into your knowledge graph? Because this is how we are querying a graph that already has data that we use Claude Desktop to inject. But knowledge graphs need to be constantly fed new information, and that's where n8n is brilliant, because it's an integration platform. So in the use cases I'll be going through, I'll show you some ingestion flows where we're actually injecting data into graphs. I've got two really interesting use cases here for graph agents. The first is a Customer360 graph that provides a single view of a customer for a business that an AI agent can interrogate. And the second is a document navigation graph. And this is really useful for highly formal legal documents where legal clauses, for example, need to be linked to definitions or footnotes or appendices. So first up, our Customer360. And when you think about customer data in the context of a business, customer data can be stored in lots of different systems depending on the context. So an e-commerce system like Shopify may hold all of the customer's online orders. The likes of Zendesk may hold all of the support tickets. Maybe there's a CRM that handles all of the leads or opportunities with that customer. And then maybe the likes of Stripe holds all of their payment information. So you have all of these disparate, isolated data silos. And there's huge benefits to actually having a single view of that customer data. both from a business intelligence perspective, but also for the likes of an AI agent to interrogate that, to help staff support that customer with their queries, or to extract out more revenue from that customer based off insights. To give you an example of how this would work, I've created this knowledge graph using dummy data for customers, orders, products, and support tickets. And we have different relationships as well. So for customers, they can place orders, they can raise queries, orders can contain products, and support tickets can be about specific products, as you see here. I had Claude generate this test dataset and create CSV files for me to import. These are the nodes, and these are the edges. And back to earlier when I described structured versus unstructured data sources, these are structured data sources. So if you look at the nodes, we have support tickets, for example, with ticket IDs, statuses, priorities, categories. And if you look at the edges, we have a table linking tickets to customers. So this type of format is very common in a relational database, which is what most of these types of software applications will be using to keep track of customer information. The key thing when building a single view of a customer within a knowledge graph then is how do you model the data? And while knowledge graphs are more flexible than relational databases, we need to make sure that we're matching on a common customer ID, for example, a common support ticket ID, product ID, etc. And your data model would evolve as you add more systems and bring in more information. So this is what this data model would look like as things stand with these 4 entities and these 4 types of relationships. Within n8n, we then need to be able to load this data into the graph. And this can be a one-off batch load of all data, but then it also needs to drip feed updates and changes. And as I mentioned, the beauty of n8n is that it's highly integratable. It has lots of connectors to different software packages, and you can use common HTTP request nodes to hit APIs of other packages. So here, for example, we're bringing in support tickets, products, customers, and orders. And because I'm using dummy data, I've just uploaded those CSV files to Google Drive. I'm looping through the files, downloading them, extracting them, and then injecting them into a query that can be uploaded to the knowledge graph. But if you were doing this for real, you would be hooking up all the various different software packages to extract out the data and inject it into the graph. And the same goes then for the relationships. So if a customer creates a ticket, you want that represented in the graph as well. So let's go through this ingestion flow end to end. At the moment, it's a manual trigger. You would more likely have that running on a schedule. There's a one-off creation of indexes in your graph database. So I wouldn't necessarily include that in this flow if it was running every time. But essentially, we're just indexing on the customer IDs and the graph IDs here. Here, we're searching for our files and folders. And that could also be a solution as well, because you could have batch extracts from different software packages that dump files into a Google Drive folder, and then this type of flow would work perfectly fine. So then you loop over the items, we download the CSV file here, we're extracting it, so turning it into JSON essentially, and then we inject it into a Cypher query template. So let's take customers, for example. Now again, I got Claude to generate this for me, but essentially what it's doing is it's taking all of the customers that I'm sending in from the CSV, and it's creating them on the graph, passing in all of the properties of that customer. So it's a simple enough Cypher statement, and with that query generated, we then just upload it to the knowledge graph. So essentially what we're doing is we're hitting this URL, and we're hitting the transaction commit endpoint, and then we're passing in the query, and away you go. And as I mentioned, there's lots of different ways that you can integrate with Neo4j in n8n. Previously, I showed you using the n8n community node, but you can just hit the API as well, as I'm doing here. But the community node would work perfectly fine too. And the other thing is you can use a Neo4j MCP within n8n as well. So lots of different ways you can achieve the same thing. And then once the nodes are uploaded, you then create the relationships, and it's the exact same process. We search the relationships or the edges folder, process the files, generate the queries. Here now we're generating the placed query, so the customer places an order, and we're passing in the customer ID and the order ID, and that's what creates that connection between those nodes. And again, just goes straight into that transaction commit endpoint, into that specific database, and with the authentication provided, it's sending in the query. So this isn't text to Cypher. This isn't an AI dreaming up a Cypher query that may or may not work. We have prepared queries that we're just injecting data into. So once you set this up once, this should work every time. So using this data loader, I was able to create and generate this graph. And with that running on a schedule, and with these files being archived into an archive folder, when a new file is dropped in, it can be processed and the graph updated. So then on to retrieval. How do you actually chat to this graph? Well, there's different user interfaces that you could have here. At a very basic level, you could have a chat endpoint. So here we have our open chat. As I mentioned, you could use the Neo4j MCP as well as the API. And just so you know, the MCP here isn't the official MCP. We could use that, but instead I'm executing this npm package. So this can essentially run on the fly. And it's using the n8n MCP community node. After playing with this, I don't actually recommend this because it's quite slow to run. So I would more likely just use the community module or just hit the Neo4j API directly. So let's disconnect these for the minute. Tell me what orders Sarah Williams has created and what support tickets she has. So that question has gone to the GraphAgent. It's hit the API. And within this tool, again, we're just hitting the transaction commit URL endpoint. And we're allowing the AI to create an arbitrary Cypher statement. And interestingly, Sarah Williams doesn't exist. There's an Emma Williams and a Sarah Johnson. I completely forgot. Let's go with Emma Williams. So that's a good example of the AI thinking on its feet there. So it's hit it a couple of times. And this is your standard text to Cypher queries now. It's passing in the query the exact same way that Claude would do in Claude Desktop when it's using the MCP. And here we go. We found the information. Emma Williams, she's a platinum customer. Total spend is there. And these are the orders. And these are the support tickets. So what's interesting is you could just have your different data silos connected as tools. You could have a CRM, you could have a payment gateway, you could have an e-commerce store. And then by asking that question, tell me what orders and support tickets, it could hit the different tools to get the result. So an agent can do this without a knowledge graph. It's just that using a knowledge graph, number one, makes things a lot faster because there's only a single source that you need to traverse and retrieve from. Number two, it makes things more accurate because you have to normalize across the different data sources. So if there was conflicting information in different data sources, that would possibly be flagged when you come to consolidate the data in the knowledge graph. And number three, you can generate hidden insights that would take a huge amount of time to figure out just by looking at the flat tables within different systems. For example, if there was a shortage on a particular material that was going into building a product, you'd be able to figure out what impact that has on the lead time of customer orders that may be forward placed for a month's time. So that's quite deep business intelligence that a knowledge graph can actually enable. And I mentioned how you can have different interfaces for this. Another interface could just be auto-drafting responses to emails or support tickets. So here, for example, it could be an email that was received from Sarah Johnson asking when will my latest order arrive. And with that executing, that can then hit your knowledge graph, which has a copy of all of the data from the individual systems to be able to return the accurate response. And that has then drafted this email to Sarah with information about the order, in which case the latest order was actually delivered. So it doesn't need to be email. This could be in a help desk like Zendesk or Freshdesk, or maybe you draft a response for your agent. So that way they don't have to go digging through the files to figure out where the order actually is. On to our second use case, which is a document navigation graph. And as I mentioned, the example here is a highly structured document. Think of legal documents, regulations, where there's a lot of cross-referencing of different clauses and different sections and subsections to different definitions or appendices. And actually providing comprehensive and accurate answers on these types of documents can be incredibly difficult. I was inspired by this article on Medium which describes this type of solution, which is using a multi-graph, multi-agent recursive retrieval system through legal clauses. So I've built a version of this in n8n. And this was also a topic of my last video where I go through the idea of context expansion, where the system can extract out a document's inherent structure based off Markdown, and then an agent can intelligently retrieve different chunks from different sections depending on what content it's getting back from the vector store. And what this looks like in reality is an AI agent that should be able to answer questions on a document like this, a formal legal document, with different article numbers and clauses. And if you take this example article, which is 610, you can see that the text is cross-referencing the article 628. So if the AI agent was answering a question on this, and it retrieved this back as a chunk, it should also be able to get the information from this to formulate a comprehensive answer. And that's what the context expansion solution is aiming to solve. But the difficulty with context expansion is it's relying on the structure of the document, and specifically headers. So while this would show up as a header, Article 6.10 or Article 6.28 would not. This is what the interconnected document graph looks like. So we have our document in the middle, which is then linked to different sections and subsections. Everything you see in blue here represent chunks of information, and everything in green are the clauses, the legal clauses within this document. And from a relationships perspective, you can see that clause 4.1m is in chunk 105, but then also chunk 116 references clause 4.1m. So if chunk 116 was retrieved by a vector store, through this graph, you could automatically load up clause 4.1m and give a comprehensive answer. This type of graph then requires two distinct stages. The first one is importing the document based off the structure of the document, the headings within it. The second then is the enrichment of the graph. It's trying to link up those references within those chunks to the different subsections within the document. And once the graph is imported and enriched, it can then be retrieved by an agent to formulate accurate answers. And this is what the graph-based context expansion looks like. So we have our document, the F1 financial regulations that we imported. We use Mistral OCR to extract out that document's markdown and that document structure. Our system uses Supabase to import the documents because we use that as a vector store as well. We then go to an LLM to enrich the document itself. So in other words, extract out a document summary. And then based off my last video, we use our smart chunker and our document hierarchy extractor to extract out the index of the document based off the heading levels. And this is what that hierarchy looks like. And you can see it's quite detailed, except it's not going down to the clause by clause level that this type of formal legal document would require. But it still works very well for the vast majority of documents. So then what I did is I transformed this hierarchical index into graph nodes and edges in this function. So we can see now we have all of our graph nodes, 250 of them, and edges, 475 of them. So this now represents the different sections and the linkages from a hierarchy perspective, and we can save that in the graph. And that's pretty much what this looks like. So we have our main document, we have the different chunks and the different sections. And this one is our definitions section, which is a large section of the back of the document, and it has a lot of chunks associated with it. But what's missing is the references that are buried in those chunks to other sections of the document. And that's where the enrichment comes in. The approach I took to graph enrichment was to load up all of the sections and chunks from the graph. Again, this is just a Cypher query. I could have got this from Supabase as well, but it's a Cypher query that's fetching all of the sections, all of the chunks, and then we go through each chunk. And what I'm doing is I'm going to an LLM to actually extract out search terms that I can go to the vector database to try to find relevant sections to link to this chunk. So here, for example, we have a chunk, which is Article 628, which is about the complaints procedures. And yeah, it actually references Article 8. You can see it right there on screen. So the idea then is because this chunk, which is in Article 6, is referencing Article 8, it has extracted out Article 8 as a search query that we can run against our hybrid search system. So then we work through this. We generate embeddings for each of those search queries. We trigger hybrid search a large number of times, as you can see, but Supabase hybrid search is well up for it. And back to that run 8 of 21. So we passed in Article 8 as the search into this hybrid search system, and it has pulled out the exact article, 8 categories of breach, and then that goes to an LLM to glean the references. In other words, to consider the results that it got from this hybrid search and make a judgment call as to whether that actually is a cross-reference or not. So if we come in here, go to 8 of 21, and actually that is it there. So you can see it's chunk index 93, Article 8 categories of breach. So it's outputted this index 93 as a reference for this chunk that it's processing. And then it's enriching the graph with that using this Cypher query here. So let's now see what that looks like in the graph. So we're looking for chunk index 70, which is this one here, chunk index 70. And as you can see, it references chunk 93. And you can verify all of this by looking at the content of this chunk. And that mentions Article 8. And then this reference to chunk 93, if we open it up, we could see this is Article 8, categories of breach. So I think that's a brilliant example of dynamic interlinking of sections within a document. And that's a great example of graph enrichment. It's where you're actually putting lots of processing power against enriching the graph. So when it comes to querying that graph then, you could be super fast. You don't need an LLM to reason over the structure or traverse or do whatever it needs to do. You can just automatically load up all connections of that chunk. The downside, obviously, is the time it takes and the cost of actually enriching it. So for this one document, like we hit hybrid search 1,100 times. We made around 400 LLM calls. This took around 16 minutes for a 50-page document. So it's not something that I would be doing at scale. I think the context expansion solution I put out in the last video is the solution to use at scale. But if you have a really tight use case where you need highly accurate responses for highly complex and interlinked documents, this is a great approach. So then when it comes to chatting to this document, of course you could just load up the full document. I won't show that because you could do that without a knowledge graph. But let's look at the neighbor and references retrieval. And let's use that example that we found. So chunk 70 is about the complaints procedure. Let's ask, what's the complaints procedure if there's a sanction for an overspend breach? Okay, so that's gone to the vector store and it's retrieved 3 results. And it's got the neighboring chunks of those results. Okay, and it has formulated an answer, which looks pretty detailed. Let's just check to see exactly what happened. So it sent in the complaints procedure, a query, run 1 of 3. So what are we looking for? We're looking for chunk 70, which is actually this one, chunk index 70. So that was the top result. This get neighbor chunks tool is passing in chunk index 70 in this case. It's looking for a window size of 3. So the 3 nodes before and the 3 nodes after, following the next relationship. So you can see the next relationship is there. So there's chunk 71. Next is chunk 72, obviously. And it goes backwards as well. And then it also gets any references. So you have references here, for example. And then based off that additional context, it can answer the question. So the same then goes for section and parent references. Instead of following the next relationship, you're following the has-child relationship. So we'll ask the same question. We get the chunks back from the vector store. Again, chunk index 70 is returned. And then we hit this endpoint, which provides 20 chunks back. We pass to the chunk index 70, and we're getting everything from that section. So you can see chunk index 66, 67, and so on and so forth. And then onto smart document traversal. This isn't using pre-cooked statements like we have here, these prepared statements. Instead, it's just text to Cypher. So the agent can figure out which direction it wants to go in the graph to answer the question. So again, back to Supabase, got our chunk index. And you need the vector store to actually find a starting point on the graph to traverse from. It then went to get the graph schema so that it understands the nodes and relationships because we haven't provided it any example. And then it's able to generate these queries on the fly, exactly the same as Claude Desktop. And there's the full answer. Again, with this text to Cypher version, you would want to lock down the actual account because you don't want to give someone delete access to the graph. But that in a nutshell is smart document traversal using a graph and is ideal for highly structured and highly complex documents where you need high levels of accuracy. If you'd like to get access to our graph-based context expansion, as well as our Customer360 GraphAgent, then check out the link in the description to our community, the AI Automators, where you can join hundreds of fellow builders all looking to leverage AI to improve their businesses and further their careers. I hope you enjoyed this video. It was a lot of fun actually playing around with knowledge graphs in n8n. I'd really appreciate if you gave the video a like below and subscribe to our channel for more deep AI and n8n content. See you in the next one.